Hi everyone, I'm Janhavi, a third year student at IIT Roorkee, and let's dive into a case study about Tesla's automated driving cars. We've almost certainly heard the name of Tesla. That's probably because of their automotive innovations. It manages to captivate the attention of the entire world due to the introduction of features like autopilot. It's probably considered to be cool because of how it represents to be a glimpse into the future of transportation. So in this video, we'll talk about what autopilot is and how does Tesla actually use it and equips it in all of its vehicles while assuring safety. Autopilot is basically an advanced driver assisting system that enhances safety and convenience behind the wheel. When it's used properly, autopilot reduces your overall workload as a driver. Each new Tesla is equipped with multiple external cameras and powerful vision processing to provide additional layer of safety. Tesla was one of the first brands to make this innovative functionality available to the public. Thanks to an array of cameras, sensors, and AI technology, most Tesla vehicles are capable of driving themselves to some degree. However, this doesn't mean that the driver can take a nap behind the wheel. In fact, none of it can be used without driver supervision, and there are some serious limitations to tech. Tesla Autopilot was the company's first autonomous mode, which was introduced in 2014. Autopilot is designed to be used with full driver supervision and is essentially an advanced version of cruise control. It has lane centering and adaptive cruise control, meaning the car can stay both in the center of the lane and can slow down or speed up depending on what's in front of it. This autopilot feature costs around $6,000, and the most expensive option on Tesla's menu is around $15,000. Why do people actually opt for features like autopilot? What actually goes behind the scene? Let's dive into that. The autopilot system is a complex system which mainly includes three parts: perception, planning, and control. Perception is usually obtained by sensors, that is, camera, lidar, GPS, radar, and sonar, to obtain information about the current environment. Decision making through the planning module predicts the next behavior, including routing planning and behavior planning. The control module involves a series of control actions on the vehicle, such as how much throttle, how to brake, or how much to turn the direction of the car, all of which is related to safe driving on the road. It only makes sense to manufacture a car which is cost friendly but also safe. So a new debate arose: cameras versus lidar. Elon Musk was not much in favor of lidar because lidar technology was still expensive and it was the only way to offer redundant perception of 360-degree camera system, and those were a must for self-driving cars. Hence, cameras needed to be good enough. The software needs to be able to recognize images, calculate distances without the expense of hardware. Having a full sensor stack, the lidar, radar, ultrasonics would add well over $10,000 to the production cost of a vehicle, which reduces the possibility of the vehicle being bought. Hence, the company opted for cameras with ultrasonic sensors. We'll look into it more. So, LiDAR is an acronym for light detection and ranging. It is sometimes called laser scanning or 3D scanning. The technology uses eye-safe laser beams to create 3D representation of surveyed environment. So, as I said before, Elon Musk wasn't much in favor of LiDAR. Hence, Tesla contains several cameras that identify objects surrounding the car. These all cover an array of different angles around the vehicle that virtually eliminate blind spots. Now we'll move on to radar and ultrasonics. So radar adds another layer of visibility to Teslas. The word radar is basically an acronym for radio detection and ranging. So what exactly happens here is that the vehicle sends out electromagnetic pulses, and if there is an object in front of you, the pulse will reflect and the signal will be returned to the car. So even if the visibility is poor due to rain or fog, Tesla will still be able to determine the distance between you and the car ahead. What happens here is radio waves are radiated out from the radar into free space, and some radio waves will be intercepted by reflecting objects or targets. In this case, they are cars right in front of you. The intercepted radio waves hit the target and are reflected back in many different directions. Some of the reflected radio waves echo back towards the radar, and this signal is received and amplified with a signal processing unit, and a decision is made whether or not a target has been detected or not. Now moving on to ultrasonic sensors. Ultrasonic sensors are wrapped around the car in a full 360-degree coverage. They work similar to radar, except instead of emitting electromagnetic pulses, they emit high frequency sound waves that can travel longer distances. Once the sound bounces off an object, it returns back to the car where it is processed in the signal processing unit. Ultrasonic sensor in itself is just an instrument that measures the distance of an object using ultrasonic sound waves. Ultrasonic sensors send out sound waves that are too high for the human ear to hear, and those waves then bounce off of solid objects, notifying the car that objects in its way. Those sensors serve more as the eye of the car, but when it comes to the brain of the car, machine learning is used. When a driver is not using the autopilot feature of the self-driving car, the car collects data on how that driver drives daily. For example, if the car finds that Mumbai roads are busier during certain times, it will preemptively reduce its speed. Since every self-driving car has this technology, the data from all self-driving cars on the road is compiled in a database. Ultimately, the future of self-driving cars in general hold the promise of safer, more efficient, and more convenient transportation for people around the world. It probably is also a very big step towards realization of scenes from a science fiction movie. And here we come to an end of this video. Hope you liked it. Hi everyone, I'm Janhavi, a third year student at IIT Roorkee, and let's dive into a case study about Tesla's automated driving cars.